everyone. In today's video we are going to discuss about Nernst equation. So Nernst equation will describe and tell us about the electrolyte concentration on the electrode potential. That means in galvanic cell we have used ZnSO4 and CuSO4 as electrolytes, right? So because of the presence of that electrolyte and because of the metals which we use them as electrodes, only the ion exchange will be taking place. That means how concentrated the electrolyte we have taken is the most important thing here. So why? Because when the electrode, that means metal, when the metal is able to react with the electrolyte solution, only then the electrons exchanging takes place. So here electrolyte plays a very important role. So electrolyte concentration means it is the substance which will dissolve electrodes or electrode materials and dissociate them into the positive and negative charged ions. So because of that charge and dissolving capacity only, the electrode potential will be produced. So how this complete process or complete function is described in the simple formula is nothing but Nernst equation. Okay. So for example, consider this general electrode reaction. Mn plus n electrons gives M. That means this is some substance. Here M is some metal, okay, and N is some number of electrons. We don't know how many electrons are losing it because it depends upon the type of metal which we are using here. So whatever the electrons it is losing here and the complete substance we will get here. So for this reaction, free energy change is delta G. We represent free energy change as delta G. Delta is represents change only. So G is for energy, which can be calculated as this formula. Delta G is equal to delta G naught plus RT. Ln values, okay. A of product by A of reactant. So here delta G naught means it's a standard free energy change. We have seen that potential electrode E and standard electrode potential E naught. The difference between this both of them is here E naught, which is a standard one, will always operate at a constant temperature and pressure, right? So in the electrode potential, so here also delta G naught means at gas constant and temperature T. So we have to consider the standard temperatures for this delta G naught, okay. So also we know that delta G means the energy which is produced. So energy it's releasing, right? So we take it as minus NFE, and for delta G naught we will take it as minus NFE naught. Here electrode potential, standard electrode potential, only this difference is there. So we have to substitute all the values in this formula, and finally after substituting the values of delta G and delta G naught also, we will get one final formula for the electrode potential, okay. That is E is equal to this electrode potential equal to E naught, standard electrode potential, minus 2.303 RT by NF. So when we substitute delta G and delta G naught values, so I'll tell you how you have to submit this. This is what minus NFE, right? So minus NFE equal to minus NFE naught plus RT ln A of product by A of reactant. I'm just writing this normally. Now when you take out this NF will be cancelled on both the sides, okay. Why? Because the same values are there. So NF. Now E is equal to minus also will be cancelled. Now E is equal to E naught. Now here what we have did is we have calculated the ln value, ln into log value. How we have to do that is we have to substitute the temperatures of the R and T, and then we have to find the ln value of this A product and A reactant. So here in this case we have substituted these values, okay. For the standard thing, for F we have used 96500, for temperature it's 298 Kelvin. So after substituting these values in this formula, we will get the ln value as 2.303, okay. So 2.303, here it will be changed to log values, not ln value, okay. We have converted the ln to log value. Now after substituting all these things, we will get, this is the final formula. And also, even after substituting this F and R values, we will get this one as a basic formula. That means we don't have to substitute again R and T. So these R and T values are this one, okay, 8.314 and 298 Kelvin. Okay, if the temperature or if the operation that you are taking place at this temperature, you can just directly use this formula. If the temperature is not 298 Kelvin and you are using it some other temperature, then you have to use this formula, because you have to substitute those temperatures here. Okay, this is about Nernst equation. So in short, what you can say is Nernst equation will describe the effect of the electrolyte concentration on the electrode potential. So it will help us to calculate the electrode potential of a cell or a battery. Okay, thank you.